So we're studying the anatomy of parabolas. We want to know, what do the coefficients do? The first question is, what are coefficients? Let's take a look at the equation of a parabola in standard form. I see that I have a term with an a. This is called the quadratic term, and that means that it is the term whose exponent is a 2. This term is also called the leading term when we write the parabola in this form, which is we take the highest term, x to the 2, followed by x to the 1, followed by, here we could say this is x to the 0. This is called standard form. This is the quadratic term. This term here is called the linear term, for reasons we're going to see in a second. And this term is called the constant term. It matches nicely with the name c. We want to know, what do each of these coefficients, the quadratic coefficient or leading coefficient, the linear coefficient, and the constant, what effect do they have on the shape of this function? So let's take a look at that. We're going to explore this at desmos.com. I'm going to click Start Graphing. What I'd like you to do is type y equals a x. I'm going to hit Shift 6 to get an exponent of 2. I'm hitting the right arrow to bring me out of that exponent, plus bx plus c, and it's offering to add a slider for me for a, b, c, or all three of them. What I'd like you to do, slide these around, take a look at if you move c, if you move b, if you move a, what effect does it have, and try to put into words what you think this a coefficient does, what the b coefficient does, and what the c coefficient does. Pause the video, do that, and come back, and we'll take a look at what each of these coefficients does. So I hope you've played with these coefficients. Now we're going to simplify things. I will just say y equals c. And let's take a look at what c does. This is saying the y value, or the height on this graph, is a constant. Let's see what that constant does. When I move c higher, let's say c equals 2, I can see that this line is through the point y equals 2, and for every value of x, I'm mapping up to a point y equals 2. So that is a constant function. Now let's make another function. I'm going to say y equals bx plus c. So I have a new function here in black. We call this a linear function because it is the general form of a line. And let's see, when I move c around, it moves around both the red function, the constant function, and the black function in the same way. And the thing it's moving is the point where both of those functions hits the y-axis here. So we call that the y-intercept, the place that the y-axis is intercepted by both of these functions. They're both moved up and down by adjusting this constant c. So you could see from when I was moving the b constant here that that is changing the slope of this linear function. So when I move b to any positive value, I'm getting a slope that's up and to the right. So I change c to 0 here. This will be really clear. When the slope is 1, b equals 1, then when I go over a distance 2, I will also go up a distance 2. When I go over a distance 1, I'm coming up a distance 1. So when I take 1 divided by 1, or 2 divided by 2, I can see that that is my slope, 1. If I make that slope 2, I can see that whatever distance I go to the right, I'm going to go twice that distance up to meet my black line here. So that's describing the slope of this line. And let's finally return to our parabola. We're going to say y equals ax squared plus bx plus c. And notice my b and c here are still 0. So the only thing having any effect is a. So let's take a look at what a does. You can see first, by a existing, it's giving us this curved shape, which you probably know is called a parabola. And let's see what happens when we adjust a. What do you think it'll do? When I make a, starting from 0.5 here, when I change it to 1, or higher, notice I'm getting a tighter curve. When I bring this back down, getting a broader and broader curve. What will happen when we bring this all the way to 0? If it's 0, we don't have this quadratic term at all, so that means we're back to a line. When I bring it past 0 to negative, I get this frowning kind of parabola curved down. So whether a is positive or negative tells me whether the parabola is curved up or curved down. It has some obvious physical significance. If we change c, you can see this still moves the parabola up and down. If I change b, obviously the black line is still tilting, but the parabola just comes in and touches that black line at a single point and then continues on its curving way. This is called a tangent to the parabola, a line that touches it at just one point. Let's change the color of this parabola to distinguish it from the line. We'll make it purple. So my purple parabola is still tangent to that black line. If I change the curvature, that relationship is still true. When I move B, I can see that I'm having a seesaw action here around that point. The tip of the parabola is actually moving along an inverted parabola. And when I change C, I'm moving the whole thing up and down. So those are the functions of the three coefficients in the parabola. A changes how curved it is. The more positive it is, the more curved up it is. If it's 0, I don't have a parabola at all. And if it's negative, then I'm going to have a parabola that's curved down. And if I bring this constant down, I can see that shifts the point where the parabola starts at the value x equals 0. So if we relate this to motion of a projectile, imagine that I start a projectile here at the point 0, 0, and I launch it over to the right. It's going to curve because of gravity and come back down and hit some distance away. That's the kind of motion we want to model here. If I change my b coefficient, that's changing the angle that I launch the projectile, and maybe something having to do with the velocity as well. We will see that in our next video. If I move this up and down, it changes the height of the launch. And the a here, the curvature, has something to do with the gravity and the launch speed and angle. So we're going to see how to relate these a and b terms to the launch speed, the launch angle, and however strong the gravity is on the planet that we're talking about. That is what we'll be looking at next. But these are the functions of the three coefficients: changing the curvature, changing the slope of the tangent to the parabola at the point that passes through the value of this constant along y, which shifts the parabola up and down.